Let us see what is refractive index and let us solve some numericals related to it. So whenever light passes from one medium to another, it always bends either towards the normal or away from the normal. This relation is expressed in the form of refractive index. Now, it can be either absolute or relative in nature. Absolute refractive index is the ratio of speed of light in vacuum or air to that of speed of light in the medium. It is denoted by n. Whereas absolute refractive index is the ratio of refractive index of medium 2 to that of refractive index of medium 1 when light is passing from medium 1 to medium 2. It is also equal to the ratio of speed of light in medium 1 to that of speed of light in medium 2. Let's solve some numericals and see how it works. The refractive index of medium X with respect to medium Y is 2 by 3. So let us write it. Refractive index of medium X with respect to refractive index of medium Y is given as 2 upon 3. And refractive index of medium Y with respect to Z is given as 4 upon 3. So refractive index of Y with respect to refractive index of Z is given as 4 upon 3. We have to find out the refractive index of Z with respect to X. So we need to calculate refractive index of Z with respect to refractive index of X. As you can see, in this ratio, refractive index of Y is missing. Let us multiply as well as divide both refractive index of Z and X with refractive index of Y. On rearranging, we will get the refractive index of Z upon refractive index of Y multiplied by refractive index of Y upon refractive index of X. Now we need the values of refractive index of Z upon Y. We have the value of refractive index of Y upon Z. So I can rearrange this or invert this and write it as refractive index of Z upon refractive index of Y is equals to 3 by 4. Similarly, refractive index of Y upon X can be taken out from this part, that is refractive index of Y upon X. We are just inverting it. It will become 3 by 2. Now from 1 and 2, I can put values here from 1 and 2. Putting the values, that is 3 upon 4 in place of refractive index of Z upon refractive index of Y, and 3 upon 2 in place of refractive index of Y upon refractive index of X. So it will become 3 3s are 9 and 4 2s are 8. That is our answer. In this question, the refractive index of water with respect to air is 4 by 3 and we have to find the refractive index of air with respect to water. We know that the refractive index of air with respect to water is inversely proportional to refractive index of water with respect to air. So we can put the values and we can find it out. Refractive index of air with respect to water, will be equal to 1 upon 4 by 3, or I can write it as 3 by 4. So the answer is 3 by 4. In this question, refractive index of glass with respect to air is given as 1.65. So refractive index of glass with respect to refractive index of air is equal to 1.65. Also, refractive index of water with air is 1.33. So refractive index of water with refractive index of air is equals to 1.33. Now we have to find out refractive index of water with respect to glass. So refractive index of water with respect to refractive index of glass. For finding this out, let us multiply both the sides with refractive index of air and divide it with refractive index of air. On rearranging this, we will get refractive index of water upon refractive index of air multiplied by refractive index of air upon refractive index of glass. So this value we already have, refractive index of water upon refractive index of air, that is 1.33. Also refractive index of glass and here we have this relation, but it is in inverted form, so we'll write it as 1 upon 1.65. So it will become 133 upon 165, and on dividing we'll get 0.806. So this is the answer.